Hi, Advanced Algebra 2. We're going to do the notes on 5.7 today, which is the binomial theorem. Okay. And what we're going to start with is something that's called a pattern, and specifically the name of it is called Pascal's triangle. Okay. So it's basically just a pattern. We're going to set up this triangle. And what you do is you're going to basically just, if you look at the pattern, the numbers right above it is what it sums to. So it always starts on ones on the outside going this way. Okay, these are always ones. The first one here is always a 1. And then, so we have a 1, 1. This is called row 1. The first one is just called row 0 because there's just a 1 there. Okay, so as you keep going though, like this 1 and this 1 add to 2. The 1 and the 2 add to 3. The 2 and the 1 add to 3. Okay, so that's how the pattern goes. You always have a 1 and a 1 on the outside, and then you just sum the ones that are above it. So here, this is called row 2 with the 3's in it. Guess what it's called? It's called row 3. Okay, so we're going to fill in a few more rows. Okay, so it starts with a 1. We're going to sum 1 and 3, so you get 4. 3 and 3 is 6. 3 and 1 is 4, and then we end with a 1. Okay, so that's called row 4. We're going to do the next row, which has 1 and 4, 5. So it's called row 5. 4 and 6 is 10. 6 and 4 is 10. 4 and 1, oops, I'm a little bit off. It's 5. And then there's a 1. So that's row 5. I just didn't go down far enough. Okay, the last row we're going to do here is row 6. So 1, 1 and 5 is 6. 5 and 10 is 15. 20, 15, 6, and 1. Okay, so that's row 6. You're just adding the numbers that are above it, and then it finishes in a 1. Okay, so you're probably like, wow, that's a nice little triangle. Why are we going to use that? Well, I'm going to show you why we find this interesting. Okay, we're going to use it for the binomial theorem. This is helpful, and we're going to look at it in this type of scenario. In AP statistics that I teach, we use binomial a lot. So there's different applications for binomial theorem. Okay, so for every positive integer n, okay, we're going to expand a plus b to the n power. Okay, so it follows a pattern, and the binomial theorem is going to, or Pascal's triangle is going to help us to write out the binomial theorem. Okay, so again, this is your official definition, and then we'll go through a couple examples. Okay, so we're going to call the coefficients, we're going to say p sub naught for a to the n plus p sub 1 a to the n minus 1 times b. Okay, plus p2, oops, and then a n minus 2 b squared. Are you starting to notice the pattern with your coefficients? I'll keep going as we go lower. We have p to the n minus 1, a, and then b to the n minus 1, plus p sub n, b to the n. Okay, where p naught, p1, all the way up to pn are numbers in the nth row of Pascal's triangle. So whatever row we have to this power, to the nth power, we're in the nth row. Okay, so those line up. Do you also notice that the exponents on your variables always have to add to n, whatever this n is? So here, like on the first one, we're going to have a to the n. When you look at the second one, a to the n minus 1, and then it's b to the first. Those exponents sum to n, and you notice that all the way down. You have a to the n minus 2, b squared. Those sum to n, okay? That is one of the things that happens in the binomial theorem as well. Okay, so here we go. What is the expansion of a plus b to the 6th power? Okay, so here our n is going to be 6. So which row are we using? We're going to use the 6th row, or row 6. Okay, so you notice the coefficients up there in row 6. We have 1, 6, 15, 20, 15, 6, 1. Okay. Okay, so the two variables we have are a and b. So the first one, we start out with p naught. Okay, the first coefficient is 1. So we're just going to start with, I'm not going to write it, but you could. But it's just a to the 6th because there's really a 1 in front of there. Okay, so this is a plus b to the 6th. This would be a to the 6th. Okay, plus, we have plus for everything since our a plus b is to the 6th power. The next coefficient for this row, we had the 1, now we're at 6, so we're going to have 6 a to the 5th and b to the what power? It's got to be a 1 because my exponents have to add to 6. Okay, plus, okay, the next number in the Pascal's triangle is going to be 15. We have a to the 4th, b squared. Okay, next one. Coefficient is 20, a to the 3rd, b to the 3rd, plus 15, a squared, b to the 4th, plus 6, a, b to the 5th, that's a 1, oops, b to the 6th. Okay, so these coefficients, 1, 6, 15, 20, 15, 6, 1. Those are straight from our row 6. And then do you notice how they're symmetric? Like here in the middle, we have the 20, a to the 3rd, b to the 3rd. And then when you go out from there, it's 15, a to the 4th, b squared versus 15, a squared, b to the 4th. And then it's the same with the 6s and then the same with the 1s. It's symmetric. That's just a pattern. Okay, so here is the expansion. All right, so this one gets a little bit trickier. Okay, what is the expansion of 3x minus 2 to the 5th power? So now we don't just have variables, we have numbers and we also have a negative that we need to keep track of. Okay, so the whole term here is 3x. That's what we used as a. And then we're going to use the negative 2 as the b. Okay, so it's going to look just the same like type of concept, but where we had an a, we're going to be plugging in 3x. Okay, okay, so it's to the 5th power, so we're on row 5 of Pascal's triangle. Okay, so what does the expansion look like? We're going to take our a, and it's going to be 2, the coefficient is 1, and I'm going to take 3x, and it's going to go to the 5th power. Okay, so plus, I now need a coefficient, so my coefficient on the 5th row, we look up there, is 5. I have 3x, but 3x is going to go to the 4th power, and I have a negative 2 to the 1st power. Okay, so those exponents again have to sum to 5. Okay, the next coefficient in the row is 10. I have 3x to the 3rd, negative 2 to the 2nd. Okay, plus 10, 3x to the squared, negative 2 to the 3rd, plus 5 is the coefficient. We have 3x, negative 2 to the 4th. Okay, my coefficient in the last one in that row is 1. 3x to the 0, so that's gone, and then negative 2 to the 5th. Okay, so that's the expansion. We just need to simplify it a little bit, okay? Because we can simplify like 3 to the 5th power. So if you know some of these, that's awesome. If not, just grab your calculator to help you simplify. So 3 to the 5th power is going to be 243 x to the 5th. Okay, so we have 3 to the 4th power, and then it's times negative 2 times 5. Okay, so this one is going to be negative. Okay, subtract. Calculate that, you're going to get 810 x to the 4th. Okay, so now we have to simplify. Oh, sorry, this is going to be plus because we have negative 2 squared, so it's a positive 4 times 10, so we have 40, and then 3 to the 3rd power. Okay, so you can use your calculator to do that if you need to. Okay, we're going to get 1080 x to the 3rd. Okay, the next one I have a negative 2 to the 3rd, so I'm going to have that still be negative. So 8 times 10, so we have 80. 3 squared is 9, so I'm going to have minus 720 x squared. Okay, the next one is going to be a plus, so we have negative 2 to the 4th. Negative 2 to the 4th, and then times by 15. Then we get 240x. And the last one is a minus 32. Okay, so that is your final expansion. Okay, so one of the questions, we'll see 2 types of questions. What's the expansion of? And you're going to have to work it all out. This is the other type of question that you'll see. What is the 4th term? So you don't need to write all of it. They just want the 4th term in a squared, 2a plus 4b to the 5th power. Okay, so we are here, 5th power. So if we look at row 5, okay, row 5 is 1, 5, 10, 10, 5, 1. Okay, so what is the 4th term? 1, 2, 3, 4. They just want just this term. You do not need to solve it all. Okay. So just for that one term, I would have 10 is my coefficient. Okay, and you can think about like this is looking at 2a. Oops, sorry. 2a. This one would be to the 5th power. 2a to the 4th. I'm just going to do just one of them. 2a to the 3rd, and so the 4th term is 2a squared. Okay, that's that 4th term. So I'm going to have times 2a all squared. So if the 2a is to the 2nd power, the 4b must be to what power? What do they always have to sum to? Well, whatever this number is that we're here. So 2, this one would have to be cubed. Okay. Okay, so here we go. Side note, the exponents always add up to the row number. Okay, that's something you want to remember. The second value here, the 4b, the one that comes second, this is to the 3rd power. It's always 1 less than. Oops, sorry, I don't know what happened there. Okay, it's always 1 less than the number that they're asking for. Okay, so the 4th term, this would have to be the 3rd. That's just something that you can remember. Okay, so simplify this. 4 to the 3rd power, 2 squared, and then times 10. That's the number. So this is going to equal, you can go ahead and calculate that. 2560. When I look here, I should have a squared, b to the 3rd. Okay. Okay, so these are just a couple of places where you can go to check out some interesting facts about Pascal's triangle. Okay, but those are the main type of problems you're going to see in your homework. The expansion, and then finding a particular term, not having to expand it all, but finding a particular term. All right, thanks you guys.